is the average velocity acquired by the electron inside the conductor when it is subjected to an external field. There is one more term, that is the mean free time. The average time between the two successive collisions is called the mean free time, or it is represented by the letter tau. So acceleration is produced in an electric field. E is given by A, F. You know that F is equal to ma, so A is equal to F upon m. F is equal to E minus E, because the charged electron that is moving in an electric field E. So the force is E, and acceleration will be A is equal to E naught upon m. So the drift velocity, from the equation we know that from the first equation, V is equal to U plus AT. U plus AT. Here U is the initial velocity. The initial velocity, due to the thermal agitation, initially the electrons, they are moving in randomly in all directions. So the initial velocity will be equal to 0, and Vd, average velocity, can be represented as Vd is equal to A tau. A we have calculated, so by putting the value, this gives the expression for the drift velocity minus E tau upon m into electric field. In place of E tau upon m, we can write another constant, that is the mu. So mu is equal to E tau upon m, and mu is known as the mobility of the electron. It is defined as the magnitude of the drift velocity per unit electric field. From this expression, we can say that magnitude of the drift velocity per unit electric field is the mobility of the electron. So mu is equal to Vd upon E, and its unit is meters square per volt per second. Now, how electric bulb glows as soon as we switch on the battery? I think this question must have been arisen in your mind. As you switch on the electric bulb, as you switch on the battery, the electric bulb glows. Now, because the typical speed of the drift velocity of the electron in the wire is only 10 raised to power minus 4 meter per second, but if an electron drifts with this speed, then the electron leaving the battery will take hours to reach the light bulb. So it must take the long time, but it does not happen, because when battery is switched on, the electrons begins to move away from the negative terminal of the battery, and this electron exerts force on the nearby electrons. So the process creates a propagating influence, and that travels through the wire with the speed of light, and in other words, the energy is transported from the battery to the light bulb at the speed of light. So due to this reason, the light bulb glows as soon as we switch on the battery. So if there is a common misconception that the battery is the source of electron, it is not true. When the battery is connected across the given wire, the electron in the closed circuit resulting the current. Battery sets up only potential difference. It does not create the electrons. The resulting electrical energy is used by the electric bulb, electric fans, and similarly the electricity board is supplying the electric energy to our homes. We often use the phrase that like charging the battery in my mobile, and my mobile phone battery has no charge, etc. These sentences are also not correct. When we say that battery has no charge, it means that battery has lost ability to provide energy or to provide the potential difference. And when we say that mobile is charging, it means the battery is receiving energy from the AC power and not the electrons. Now similarly, we can solve this example very easily. Now, microscopic model of the current. Consider a conductor with the area of cross-section A and electric field E applied from right to left. Suppose there are n electrons per unit volume in the conductor, and assume that the electron moves with the drift velocity d. That is, n is the number of electrons per unit volume, Vd is the drift velocity. Then this is the diagram, that Vd is the velocity. Now, so the number of electrons in the volume, this is the distance which they have moved. The drift velocity is Vd. The electron moved through a distance dx, then through a small distance, then d is equal to dx upon dt. So from here we can say that dx is equal to Vd upon dt. So an area of cross section, so total volume will be volume into number per unit volume. total volume means the total number of the electrons, that is volume, and number of volume, total volume is A dx, and number per unit volume is n. So the total number of electrons in this volume is A dx into n. Now as we know that charge on one electron is E, so total charge can be given as E is equal to AVD dt into n. So the total charge in the volume will be given by this. So the current through this volume will be given dq by dt by putting this value, and we get a relation I is equal to NEAVD. This is all very important relationship between the current and the drift velocity. Now current density. The current density is defined as the current per unit area of the cross section of the conductor. SI unit of the current, that is area A ampere per meter cube, and the value is J is equal to I upon A. If you put the value of I, then it will reduce to NEAVD. So we can say that current density I is equal to NEVD. Now the above expression is valid only when the direction of the current is perpendicular to the area A. In general, the current density is a vector quantity and it is given by J is equal to NEVD vector. Substituting the value of Vd, it reduces to J is equal to minus Ne square tau upon m into E, and in place of Ne square tau upon m, we can write the another constant, that is sigma, and it is known as the conductivity. So this equation is called the microscopic form of the Ohm's law. So J is equal to minus sigma E dot. Just like in the Ohm's law, V is equal to IR, or V is equal to IR. So it is known as the microscopic form of the Ohm's law. The inverse of the conductivity is called the resistivity. So resistivity M is equal to Ne square upon tau. About the resistivity we will study later on. Now similarly, on the basis of this we can solve these example this. So thank you.